Hello, George Romanic here. Welcome to Fundamentals of Weather and Climate playlist. In today's video we are going to talk about protecting crops from cold temperatures. And this video will be split in two parts. First we are going to talk about length of the growing season, and then we are going to define growing degree days. In terms of the length of the growing season, if this axis is time, t, then the growing season is defined as the time interval between two dates, indicated with these blue lines. Now, what are these two dates? Well, this one is the last day in spring that is characterized with killing frost. And this date is the first day in fall that is characterized by the killing frost. But how do we practically determine these days? Well, usually this is the last day in the spring when temperatures dropped below 0 degrees Celsius, or they were equal to 0 degrees Celsius. And this is the first day in the fall season when temperature was equal or below 0 degrees Celsius. So this in between is growing season. So it is clear by looking at this and from definition that I just outlined that the length of the growing season depends on the geographical parameters of that field. For example, with increasing latitude, the growing season shrinks. Higher in mountains, where we have very cold weather, the growing season can be shorter. Close to large bodies of water, such as lakes, growing season can be locally lengthened. In valleys, growing season tends to shrink because of the drainage of cold air from mountain slopes that go into valleys. So you see, the growing season is not some fixed number, but it depends on location. However, in addition to these geographical parameters, the growing season also depends on the type of the crop that we want to cultivate. Because killing frost that we discussed a few minutes ago might be killing for one species of crop, but not for some other species. So the length of the growing season therefore does depend on the crops. For example, rice and cotton are much more susceptible to negative temperatures and freezing than some other species like wheat and so on. Then number two, what also is important is the rate of freezing. When we have very sudden, quick, rapid freezing, then usually what happens, large ice crystals are formed, and these large ice crystals tend to damage plant tissues much more than small ice crystals that form when the rate of freezing is slow. Then three is duration of the sub-zero temperatures, because plant tissues tend to freeze gradually. If the period of negative temperature is very short, then the damage to the plant is not going to be as profound compared to long sub-zero temperature periods. And lastly, how killing is the frost also depends on the stage of plant's life cycle. Seeding stage is much less susceptible to freezing than flowering stage. However, even when temperatures are above zero and we don't have killing frost, it doesn't mean that all temperature intervals are equally good to sustain growth of plants or different crops. And this is where the concept of growing degree units come in. Corn, for example, grows very little when the temperature is below 10 degrees Celsius, and it also grows very little when the temperature exceeds 30 degrees Celsius. So, keeping in mind these two numbers, how do we define growing degree units for corn. There are 4 steps. Number 1, find daily minimum and daily maximum temperatures. 2, if daily minimum temperature is below 10 degrees Celsius, then set minimum temperature to be 10 degrees Celsius. Because, why 10? Because I just told you, corn doesn't grow well when temperature drops below 10 degrees Celsius. Similarly, if this maximum temperature exceeds 30 degrees Celsius, because corn doesn't grow well when temperature exceeds this value, then set maximum temperature for that day to be 30 degrees Celsius. This value of 10 degrees Celsius is also known as the base temperature. And clearly now different species, different plants will have different base temperatures. Corn has 10 degrees, but you will see later that some different plants have different values. Now, step number 3. Calculate daily average temperature T over bar equals T minimum plus T maximum divided by 2. So simple arithmetic mean of these two values. And then last step, step number 4. Growing degree units is equal this average temperature minus base temperature, which is 10 degrees Celsius for corn. And this formula is the formula for growing degree units for corn. Let's give a quick example. Let us say that maximum temperature on a given day is 20 degrees Celsius and minimum temperature on a given day is 10 degrees Celsius. Is 20 larger than 30? It is not, so we keep it as it is. Is 10 smaller than 10? No, so we keep it as it is, that's 10. From here, calculate T average. T average, step number 3, is arithmetic. So 20 arithmetic mean. 20 plus 10 is 30, divided by 2 is 15 degrees Celsius. And then step number 4, calculate GDU using this formula. So GDU will be 15 minus 10 is 5. Quite often people leave it without units, but you can see that officially unit would be degrees Celsius. Regardless, this particular day has 5 growing degree units. And growing degree units are used in accumulated way. For each day, one calculates this and then adds the value of the previous day, and so on. So how is then this used? Well, it is used as a cumulative value. In other words, when growing degree units reach certain value, 100, do this. Either start seeding or do first cultivation action of this type. When growing degree units reach this value, do this, do that. So farmers can make decisions what is the best action for their crop based on the accumulated value of growing degree units. Let us now see what are the base temperatures for different plants typically used in agriculture. Behind me is a map for growing degree days or growing degree units, that's the same thing, for base 10 for Canada. And this is a climate normal, namely climatological average for the period 1991-2020. You can see in the legend that these are accumulated values over the year. Notice that the southern parts of Canada have more growing degree days than the northern regions, because here we have colder climates. Also notice that here, close to big bodies of water such as Great Lakes, and we are approaching the Atlantic Ocean, the number of growing degree days is larger than further inland, and that's what we discussed in the first part of this video. You can see the same thing here in Newfoundland, where the region has more growing degree days than the same latitude but further deep in the land. Now, if we go to a simple table where here we have base temperature and here we have different crop species, then, as I discussed in this video, corn as well as sweet corn have base temperature of 10. However, some other species, such as lettuce, asparagus and whatnot, have base temperature of 4, whereas sunflower and potato have base temperature of 7. So you would use these values in the calculation of growing degree units. And lastly, it turns out that the growing degree units or growing degree days can also be used to predict the onset of insects attacking plants, infestation of insects attacking different plants. And the base temperatures are different if one is looking into insects compared to the growing of plants. So, for example, corn rootworm has the base temperature of 7. Again, how is that used? In accumulated way. When you calculate growing degree units for every day and you accumulate them, for example, when the value reaches 70, then perhaps this insect is likely to attack some plant. I don't know if it is 70, I just made it up, but I'm saying how it is used. I know for corn, when the values are around 100, 120 growing degree units, it is expected that the corn might emerge from the soil. For example, I remember that one. So that's how farmers and experts in this field are using these measures. Make sure you like and subscribe. Please share and comment on this video. And until next video, goodbye.